Today we're going to talk about the function characteristics, extrema, and increasing and decreasing intervals. First, let's talk about extrema. Extrema comes from the word extreme. The maximum and minimum values of a function are called extrema. So if we look at this graph, the top of the mountains and the bottom of the valleys are called relative extrema or local extrema because they are the highest or lowest part of their neighborhood, that particular area. So you notice this first yellow point here is the highest in this section of the graph, so that's a local maximum, but it is not the highest of the graph overall. The second point here would be higher than the first, but because it's in a different area of the graph, they are both considered local maximums. Here, this minimum point right there, it's not the lowest point of the whole graph, but it is the lowest point in this section, so it is called the local minimum. We call absolute extrema the highest and lowest maximum and minimum values of the entire function. So when you have a maximum value and it is higher than all of your local maximums, that would be considered your absolute maximum. Same thing with your minimum. If there is a lowest point of the graph, there's no other point below it, that would be your absolute minimum. So your local maximum or minimum will be in that section of the graph. One of those could be an absolute maximum or minimum. Sometimes we call this global because it does encompass the entire function. Now, a function does not always have to have an absolute maximum or minimum. We'll see some of these when we practice today. Now, before we start really working with our extrema, my best advice in starting out with these would be to get a small object that can help you out at first. And it can be just something small that you have around the house. Perhaps if you have a mini toy car or a small piece of candy. A small little bug eraser is my favorite thing to use. And before long, you won't actually need it. Let me show you how we're going to use those. Here's our first example. We're going to label all of the extrema. This particular graph is a little more complex than most of the ones we're going to be working with today. But it's a really good example to show you some of the different kinds of extrema that we have. So I'm going to start off in looking for our extrema with the one thing you really should write down. If you don't write down anything else today, write down that what or is means why. What is the maximum or minimum? The maximum or minimum is, that means your y value. Where or the minimum or maximum is at, that means x. So if you don't write anything else down today, write down these two things. What means y, where means x. Now we're going to start on this left side of the graph. And I see here I have a point. It's not an arrow. So this is actually where the graph starts. It doesn't go beyond this -4 right here on the x-axis. So this point is at -4, -1, and I'm going to write this down here in our table. So this would be considered a local maximum because it is the highest point in this area of the graph. So what is it? Remember, what is y, and the y value here is -1. Where is the max or min? That's our x value, our x-axis. Where is it? It's at -4. This one is a local maximum because there are other points higher on the graph, just not in this particular neighborhood. Now, here's where we're going to use our small object. What I'm going to do is I'm going to start at this very point here on the far left, and I'm going to use my little toy car this time, and I'm going to trace along this graph. So when my car is going down or when it's going up, and it changes direction. So here, for example, we'll go down, we'll change direction here. That's where I'm going to pause, and I'm going to look at that point. Our extrema is at the changes in direction on our graph. So my car is going to go down. And here's where we would change direction. So I'm going to put a point right there. That's going to be another extrema. So this ordered pair is at -3, -2. I'm going to put that down here in my chart. It is a minimum. It is a lower value. I'm coming from decreasing here, and then I'm going uphill. So I went downhill and then uphill. So this is a low point. This is one of my valleys. So that's a minimum. What is the minimum? Well, what is y? How low is it? Or at what point for y is that minimum? And that is at -2. Where is the minimum? And where is always x. We measure that on the x-axis, so it is -3. Is it local or absolute? Well, I see there are points over here lower than this one, so it is only a local minimum. Now, I'm going to take my toy car, and I'm going to trace again, and here is where I would change direction, so I'm going to stop and put a point, and that is at -1, 2. So I'm going to fill that in my chart. Now, this is a high point. My car is on top of this graph right here. Everything's below it in this area, so it's a maximum. And what is the maximum? So how high is it? It is at 2. That's our y value. Where is it? That's our x-axis, -1. And is it local or absolute? If I look further down the graph, there is a point here where my car would get higher when I trace there. So it is only a local maximum. Now, I'm going to continue tracing with my toy car. And here's where I change direction. So here's where I'll put a point. And that is at 2, -6. Now, my car is at the bottom of the graph here. So in this area, the graph is above the car. So that's going to be a minimum. What is it? Well, how low is it? It's -6. Where is it? That's x. That's 2. Is it local or absolute? Well, let's hold off on that for just a minute. I see an arrow up here. So we're going to talk in just a second about which one is going to be our minimum. So let's leave this blank, and then we're going to continue tracing with our little toy car, and we will come back to this part. So I'm going to continue tracing. My car is now going uphill. Here's where we would change direction. It is on top of the graph. That is where I'm going to put another point. And that point is at 4, 5. My car is way up on top of it. Everything's underneath, so this is a maximum. What is the maximum? Well, how high is it? It's at 5. Where is it? And the x value is 4. Is it local or absolute? Well, if I look at the graph, this is the highest point. There's no arrows making anything go higher. This is the highest point, so it is an absolute maximum. All right, so now we left one blank here. Let's see which is going to be our minimum. I'm going to continue taking my car, and I'm going to trace. So when I get to this arrow, keep in mind my car is going to keep going, something like that. Well, that just went way down there, which means it went below this point. So that is not an absolute minimum. I will put local right here, because this arrow is going to go all the way down to -infinity. We have no absolute minimum for this graph. Now, this one looks a little more complicated. However, the absolute value and quadratics that we're working with right now are much simpler and a lot easier to look at with our extrema, as well as our increasing and decreasing intervals that we'll get to in just a moment. If we look at our absolute value and quadratic functions, let's first look at the ones that open up. So if they open upwards, you see both arrows are going up. We have a vertex at the bottom. So our vertex is the lowest point on the graph. So these types of functions that open up will have an absolute minimum where the vertex is. It will have no absolute maximum because the arrows go up to positive infinity. If they open down, our highest point is at the vertex, and they go down to negative infinity. So the highest point is going to be our absolute maximum. And because it goes to negative infinity, there are no absolute minimums. Before we wrap up our video today, we're going to look at some examples. with these types of equations. But first, let's talk about our increasing and decreasing intervals. Now remember, when we're talking about intervals, we talked about interval notation just last week. So that is where we would have our intervals written in either parentheses or boxed in. We'll talk about those in just a minute. First, let's take a look. At every maximum or minimum where there's a change in direction, those are our extrema. So at each extrema, that is a point where it changes from increasing to decreasing or decreasing to increasing. So these occur over intervals, and we use the x-axis to name the intervals. I'm going to use my little ladybug eraser this time. We're going to trace over it. Right now we see it as increasing as we go uphill. And you see at this point we would change direction. As we go downhill, we're decreasing. As we go uphill, we're increasing. And you see here we're constant. So at this point where it's constant, the ladybug is tracing straight across. And the arrow means we're going to keep on going. So we will use our x-axis for our intervals. We'll look at this example in just a moment. Now remember, we can write the intervals as inequalities, or we can use our interval notation. Today we're going to primarily focus on interval notation. So let's take a closer look at this graph and actually write down our intervals. So to join our interval notation, we use a math symbol for union. So here we have multiple increasing intervals. So we'll use a union symbol in between the different intervals. So first, though, let's find out what our intervals are. I'm going to take my ladybug, and you notice the ladybug comes up from the bottom because we have an arrow here. So it's coming up from negative infinity. So that's going to be the lowest point of this interval. My ladybug is going to go uphill. We stop where we change direction. And I'm going to draw a dotted line through the graph. When I draw it through the x-axis, that reminds me that we're talking about the x values for our intervals. And if I count back from the origin, since we don't have any numbers here, I go back 1, 2, 3. So this is a negative 3 on the x-axis. So my first increasing interval is from negative infinity to negative 3. Now, in the interval notation we've used before, remember our squared off brackets are for including the number. At this point where the direction changes, at this point we are not increasing or decreasing. It is right in between. So we always use parentheses for our increasing and decreasing intervals. So this interval would be negative infinity to negative 3. Now, I'm going to take my ladybug and I'm going to trace again. We're going to go downhill to this point where we would change direction. Draw my dotted line through the x-axis. And if I count from the origin, this is at 1. So my interval here for decreasing is from negative 3 to positive 1. And again, I use parentheses because where it changes direction, it is neither increasing or decreasing. Continue tracing from 1 up here. We're increasing. We're going uphill. Draw my dotted line. I count 1, 2, 3, 4. So this is a 4 on the x-axis. So from 1 to 4, we are increasing. Now here's where we were at our constant. Our ladybug is tracing straight across. It's not going uphill. It's not going downhill. So we keep going this way. Now if we continue going on, this arrow shows that we're going to go on towards positive infinity. So from 4 to positive infinity, we are at a constant. Now we need to write these out. So our increasing intervals we saw were at negative infinity to negative 3. But we also have one over here. We draw our union symbol. In between that and our 1, 4. So negative infinity to negative 3 are increasing here from 1 to 4. union symbol in between. We had a decreasing interval here at -3 to 1, which we put here at the bottom. And then we have a constant interval from 4 to positive infinity. For our absolute value and quadratic functions, these intervals are significantly simpler. We actually only have exactly one increasing interval and exactly one decreasing interval for each absolute value and quadratic function. We do not have a constant interval at all. So let's take a look at a couple of examples. In this first one here, we have the graph of -x squared minus 2x plus 3. So we have a quadratic, and what I'm going to do is I'm going to trace it. So this time I'm going to use a candy gummy bear, and you notice I come up from the bottom because there's an arrow here. I'm coming up from -infinity, so that's the start of this interval, and I'm going to trace. My bear is going uphill, so that is increasing, and we're going to draw our dotted line through the x-axis. Uphill is increasing, and then I see that where I stop increasing and change direction, that's where x is -1. So from -infinity to -1, I'm increasing. Now I'm going to continue tracing with my candy gummy bear. Here we're going downhill, and you notice we've got an arrow, so it's going to keep on going. So we went downhill, decreasing. At the arrow, we keep on going. So that's going to keep going all the way to positive infinity. So from -1 to positive infinity, we are decreasing. Let's fill in our blanks over here. For increasing was -infinity to -1. Decreasing was -1 to positive infinity. And constant, we have none. Let's try another one. Here we've got an absolute value. So I am going to start by tracing over here. And you notice with the arrow, I'm coming in from -infinity. I'm going to trace using my piece of candy. And here's where we change direction. So this is where I'm going to put my dotted line through the x-axis. That divides my interval. And that is here at -2. We are decreasing. We were going downhill. -2 is the end of this interval. So I write for my decreasing interval, -infinity to -2. Continue tracing. My piece of candy is going uphill now. So it is increasing. And we've got an arrow. So that piece of candy, we're going to keep on tracing, and that's going to keep going towards positive infinity. So my interval here for increasing is from -2 to positive infinity. Fill in our answers over here on the bottom left. So our decreasing was first, -infinity to -2. Our increasing was -2 to positive infinity. And we had no constant interval. All right, that is it for our video on extrema and increasing and decreasing intervals. Let's go ahead and practice a little bit together before we do some work on our own.